Today I want to start by thanking you for all your prayers. Thank God the surgery went pretty good. I'm waiting to hear from the doctor and get released, so I hope to be back soon. I don't know if that's good news for you all or not, but it's good news for me. I'd like to be back teaching again. Today I want to talk to you about how to find the area of some other figures, starting today with a parallelogram. And again, finding the area of a parallelogram is kind of challenging because if you remember, to find area, we need to find square units, okay? And again, just like with a rectangle or a quadrilateral, okay, or a rectangle or a square rather, you can measure the sides of the parallelogram, okay? But then now, when you go to draw your squares, you'll get some squares, but you'll also get some other figures. This is a quadrilateral, trapezoid, another trapezoid, a triangle, a couple of squares in the middle, and then another triangle, trapezoid, trapezoid. So again, I can't say my area is 9 squares, 4 trapezoids, and 2 triangles. I need it to be in squares. But how do I do that when this figure doesn't have a straight edge? Well, to find the area of a parallelogram, the first thing you do is you cut it right on here. And again, if I could find the area of these two things, that would represent the area of this whole thing. So if I had this area added with this area, that would be the area of the parallelogram, all right? But again, you say, well, how are you going to get the area of these two? Well, hocus pocus dominocus, I swing this around to this side, and I get a rectangle. And if you remember, the area of a rectangle is length times width. Except now, the length of this thing is the base of the parallelogram. And the width of this thing is the height of the parallelogram. So instead of saying that the area of a parallelogram is length times width, it's actually base times height. Because you can take your parallelogram, okay, and you can convert it into a rectangle, the same exact area, by cutting the one part off and moving it. So again, the area of a parallelogram is equal to base times height. By the way, I was grading your homeworks on perimeter, and I was very disappointed in the fact that a lot of you weren't using the formula first, replacing the value for the variables, and then the answer. So if I was to give you a parallelogram like this on homework, and I told you the height was 4 inches and the base was 6 inches, and I asked you to find the area, I'd expect you to say area of a parallelogram equals base times height. I expect you to start with the formula. Then you can replace the base with 6 inches, you can replace the height with 4 inches, and then you can multiply 6 times 4 is 24, and inches times inches give you square inches, or if you prefer, 24 inches squared. And again, when I grade your homework, I need to see the formula first, I need you to replace the variable with the value second, and then get the answer. Okay, you cannot just work it out and get the answer because you're not going to get credit for that. On the homework that you did on perimeter, each problem was worth, I think, 5 points, maybe 6 points. The formula was 2 points, replacing the variables with their value was 1 point, and the answer was 3 points. So you could get all the answers right, a lot of you did, but not get a good grade because you need to have the formula first, all right? So again, the whole idea of finding the area of a parallelogram is to take and cut off part of the parallelogram and swing it to the other side and make it a rectangle, which is really length times width, but in the parallelogram, the length is the base and the width is the height. So length times width becomes base times height. Now, the next thing we want to talk about is how would you find the area of a triangle? And if a parallelogram was going to cause you trouble, a triangle really is going to be challenging. Because again, there's no square part to a triangle at all. If I was to measure the distance of each side of the triangle and draw to cut my parts like I did in the square and the rectangle, okay, I don't get any squares. And I get a whole bunch of different figures. Triangles, okay, pentagons, okay, trapezoids. There's all type of different figures in here, but there's no squares at all. And you say, well, then how do you find the area of a square, of a triangle? Well, to do that, first of all, would you agree that if I could find the area of two triangles, then what would I have to do to find the area of one? Wouldn't it be to divide it by 2? Because if I knew the area of two triangles, then I need half of that for one triangle. And you say, but Mr. Adu, how can I find the area of two triangles when I can't find the area of one triangle? And I say, hocus pocus dominocus, what I wind up getting here is a parallelogram. I can take the two identical triangles and put them together to make a parallelogram. Okay, and if you would notice, all right, the base of the triangle is the same as the base of the parallelogram. And the height of the triangle is the same as the height of the parallelogram. So if the area of a parallelogram is base times height, and that makes two triangles, then the area of one triangle must be base times height divided by 2. So the formula for area of a triangle is base times height divided by 2. Or sometimes this is written 1/2 base times height. Because to multiply something by 1/2 is the same as to divide it by 2. I normally use this one, but I noticed that a couple of years ago someone mentioned this one, and ever since my classes usually like to use this one better. So if you prefer to do base times height divided by 2, you can use this formula, or you can take 1/2 base times height. And again, it's not magic, and someone didn't just make up the formula. It comes from logic. It comes from the fact that if you knew the area of two of these, the area of one of these would be if you took the area of two of them and divided it by 2. So if you took two of these and you put them together, you get a parallelogram, which is base times height. So one of these would be the base times height divided by 2. All right? In the same way, the last type of figure we want to talk about today is a trapezoid. Okay? And again, a trapezoid has a challenge, because if you were to measure the distances on the trapezoid and then you were to go across, okay, like we did, again, you would form some squares, but you would also form some triangles, you would form some pentagons, you would form some rectangles, and you'd form some trapezoids. And you would have a big mess. Actually, I said you'd form some squares, but it doesn't even look like you have any squares in there. All right, so how would we find the area of a trapezoid? Well, again, let's go to the concept of 2 of these instead of 1. And again, if I had 2 of these instead of 1, okay, if I could find the area of 2 of them, I would divide it in half to find the area of 1, because I have twice as much with 2 of them than I have with 1. So to take half of it or divide by 2. And you say again, well, how do you get the area of 2 of them? Hocus pocus dominocus, you come up with another parallelogram. But this time, the base of the parallelogram is both base 1 and base 2 added together. Now the height is still the same, but the base is the two bases added together. So again, the area of parallelogram is base times height, but in this case, the base is base 1 and base 2 added together. So the formula for the area of a trapezoid comes out to equal base 1 plus base 2 times the height divided by 2. Or, again, I've seen it written 1/2 the sum of base 1 and base 2 times the height. And again, whether you use the formula for area of a parallelogram, area of a triangle, or area of a trapezoid, it's just a matter of first, write the formula, second, replace the variable with its value, and finally, to work it out using the order of operation. So, if I gave you a triangle that looked like this, which is kind of a strange looking triangle, the first thing you have to understand is that these are the sides of the triangle. Say this was 7 meters, 6 meters, and 5 meters, and say this was 4 meters. And you need to understand that this dotted line is from the very top straight down, so this is the height. But it's a dotted line because it's really not part of the triangle. So if I wanted the perimeter of this triangle, it's not a special triangle, so it's just side 1 plus side 2 plus side 3. So to get the perimeter, you'd go 7 meters plus 6 meters plus 5 meters. And 7 and 6 is 13 and 5 is 18 meters. But to get the area of the triangle, you could use base times height divided by 2. And again, the base is 5 meters times the height is the imaginary dotted 4 meters, and then you have to divide by 2. And 5 times 4 is 20. Meters times meters would be meters squared divided by 2, and 20 meters squared divided by 2 is 10 meters squared, or 10 square meters. And again, the whole key to working with the formula is to pick the right formula first, replace the variables with their value, and then work it out. And also remember, perimeter is a straight measurement, like 18 meters, and area is a square measurement, like 10 square meters. And again, this is what you're going to use for your homework tonight. 3 new formulas. Area of a parallelogram is base times height. Area of a triangle is base times height divided by 2, or if you prefer, 1/2 times the base times height. And area of a trapezoid, the sum of the bases, base 1 and base 2 times the height divided by 2, or 1/2 base 1 plus base 2 divided by 2. And again, you don't really need to understand where the formula comes from, but I like to show it to you because, to be honest with you, when I was in school, no one showed it to me. They just gave me formulas and said memorize them, and they didn't make any sense. Okay, when I learned where it really came from, I said, wow, I wish I would have known that's where it came from. Because maybe if you get stuck, you could figure it out by looking at where it came from. Thank you again for all your prayers, and I will be back soon, hopefully maybe by Tuesday or Wednesday. No later than Thursday, though.